Hi everybody, welcome to another Saturday session with Exam Revision. So my name is Kate and today we're going to be going through the topic of trigonometry for junior cycle higher level maths. So by the end of this session, hopefully we'll be able to use Pythagoras Theorem to find a missing side. And then our trigonometry ratios, so sine, cos and tan, we need to be able to use those to find a missing side and also to find a missing angle. Okay, and then we're going to look at some real life problems using the above method. Okay, so Pythagoras and sin, cos and tan, which you're going to be referring to as SOHCAHTOA, they're the two main parts of trigonometry. Okay, so we're going to start with Pythagoras, then we're going to go to sine, cos and tan, and then we'll look at a few exam questions. Okay, so for trigonometry, Pythagoras' theorem is one of the methods we can use. Okay, so trigonometry always deals with right angled triangles. So every triangle we're going to see today is going to be right angled. Okay, right angled means it has a right angle in it or a 90-degree angle in it. We usually use this symbol here in the corner to show that an angle is a right angle or 90 degrees. Okay, so Pythagoras' theorem is a formula that's given to you in your formula book. So the formula is c squared is equal to a squared plus b squared. Okay, and a diagram is also given to you in the formula book. Okay, so Pythagoras' theorem, the only important thing about using this and the most common mistake is that the c squared, so the bit on its own at the other side of the equal sign, must be the hypotenuse. Okay, it must be the longest side. To find that, it's always the one opposite the right angle. Okay, so c, the one on its own, must always be the longest side. Okay, and then I suppose the question you'll be asking, maybe not right now, but after going through the two methods, is when do you use Pythagoras? You know to use Pythagoras when you know two sides and you're looking for a third side. Okay, we can't do this unless we know two sides. Okay, so for Pythagoras' theorem can only be used to find a missing side and can only be used when you know two sides and you're looking for a third side. Okay, so we're going to look at some examples here and that'll make using the formula a little clearer. Okay, so here we're obviously solving for x, so we're looking for a missing side. Okay, I think, okay, I can use Pythagoras' theorem because number one, it's a right angle triangle, and number two, we know two sides, we're just looking for the third one. So I'd go to my formula book and I'd write down that c squared is equal to a squared plus b squared. First thing I need to do, I need to label my hypotenuse or find the one opposite the right angle. Okay, so I'm going to label this as c. Okay, once you've that done, then a and b actually don't matter, so I'm just going to put a here and b there. Okay, just label c first. After that, a and b, pick whichever you like. So we're going to set this up now. So instead of writing c squared, I'm going to write x squared is equal to 12 squared plus 5 squared. So that means x squared is equal to 12 squared, always check these on a calculator, is equal to 144 plus 5 squared, which is 25. So x squared is equal to 169. Okay, now we're not looking for x squared, we're looking for x. So if we want to get rid of a square, what we do is we get the square root. So it's going to be x is equal to the square root of 169. So x is equal to 13. Okay, now look at our triangle, that looks about right. So we've one side 12, one side 5, one side 13. If I got an answer there of say 169 and you forgot to get the square root, you should be thinking, okay, that doesn't look really in proportion for the triangle. Okay, next one, exactly the same thing. So we have a right angle triangle, we're looking for a missing side, we know two sides, so we go straight for Pythagoras. So in an exam, you'd write down the formula. And first thing, label your hypotenuse. Hypotenuse is opposite the right angle, so it'll be there, and then again, a and b don't matter. I'm going to fill in my formula, so it's c squared, which is 17 squared, is equal to 15 squared plus x squared. I'm going to put all these numbers in my calculator separately, so I'm going to do 17 squared, that's 289, is equal to 15 squared, which is 225 plus x squared. Now, at this point, we need to do some algebra. Okay, so it kind of just shows how important that, I guess, you're on top of your algebra because it comes into every other topic, okay? It comes into trigonometry quite a bit. But it's fairly straightforward algebra. So we want the x squared on its own. So we need to get rid of this 225. To get rid of that 225, what we're going to do is we're going to subtract it from both sides. Okay, so we're going to subtract 225 from that side and from the right hand side. So they'll just cross out, they'll cancel each other out. So we'll be left with 289 minus 225 is equal to x squared. I'm going to tidy that up a bit. So 289 minus 225 into my calculator gives me 64 is equal to x squared. And now we're back again. We should know what to do from here. To get rid of a square, you just get the square root. So the square root of 64, x is equal to the square root of 64, so x is equal to 8. Okay, again, that makes sense in the context of the question to have a side of 17, 15 and 8. Now that may not be drawn very well to proportion, but it still sounds like a believable answer. Okay, so that's Pythagoras' theorem. That's really all there is to it. It can't get any more difficult. The most difficult thing is recognizing, number one, that it's time to use Pythagoras' theorem, and number two, that you get the right side as the hypotenuse. Okay, after that, your A and B don't matter. You can pick whichever one you want. Okay, so that's Pythagoras' theorem finished. We're going to come back to this when we're doing exam questions afterwards. Okay, now, the second part of this chapter is the trigonometric ratios, okay? Sine, cos and tan. Now, you may have been taught there's loads of different ways to teach this, okay? So you need to remember the formulas, okay? So basically we need a way of remembering these. So we need to know that sine is equal to opposite over hypotenuse. We need to learn that cos is equal to adjacent over hypotenuse. And we need to know that tan is equal to opposite over adjacent. So to remember that, I use the, I guess you call it a rhyme, so, ca, toa. So, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay? If you have your own way of remembering it, that's fine. Just make sure you know some way of remembering it. Okay? And now to label our sides, that's going to be really important for all of these questions. So when we're talking about A, we mean an angle. Okay, so sine A, that's our angle down here. It's never the right angle. Okay, so it's not going to be that angle there. It's going to be either here or here. Okay, we'll know that given by the context of the question in a minute. Okay, so then you mark on your sides. Always label the hypotenuse first. Okay, remember the hypotenuse, same as for Pythagoras, will be opposite the right angle. Then we've our opposite from the angle in question, so the angle A here will be over there, and adjacent means beside, so that will be there. So once you have your hypotenuse in, then you label your opposite, and then the adjacent is usually the last one I do. Okay, so labeling our sides will be super important, as is remembering our formulas. I think SOHCAHTOA is a nice way to remember it. If you were given another rhyme, that's fine, as long as you can remember your formulas. Okay, now, first thing we're going to use SOHCAHTOA for is to find a missing side. So this question says, find the length of BC correct to 1 decimal place. So we are looking for, we'll just highlight the side we're looking for. We're looking for BC, which is that side there. Okay, we can see we have a right angle triangle. The first thing I'd usually think about, okay, can I use Pythagoras? I look at it, I see I know one side, but I don't know any other sides, so that rules out Pythagoras. The second Pythagoras is ruled out, you go, okay, must be SOHCAHTOA. Okay, so what I've written here is you can't use Pythagoras because we only know one other side, so I know I'm going to have to use SOHCAHTOA. Okay, so sine, cos or tan. First thing I'm going to do is I'm going to label my sides. So here I labelled my hypotenuse first, that's opposite my right angle. And then I have my side opposite the angle in question, so I know that this is 35, so I'm going to be kind of focusing here. So my opposite side would be x, and my adjacent side will be down at the bottom there. Now, we need to decide which ratio to use. So I'm going to write them all out here. So sine is opposite, so we write OPP for short, over adjacent. Cos is adjacent over hypotenuse, and tan is opposite all over adjacent. Okay, so the first thing I think about, okay, the adjacent side here. If we don't know it, we're also not looking for it. Okay, don't know it, not looking for it means I don't care about it at all. So anyone with, sorry, that should be hypotenuse there. Sorry, I wrote down adjacent, that should be hypotenuse. So anyone with adjacent in it. We don't know the adjacent, we don't care about the adjacent, so we'll get rid of any of the formulas with adjacent in it. So tan has adjacent in it and cos has adjacent in it. Okay, basically that leaves us then with sine. Okay, sine includes everything we need, so it is the opposite, which is the bit we're looking for, and also includes the hypotenuse, which is the bit we know. Okay, so once I've decided then on sine, I'm going to fill it in. Okay, so sine is equal to opposite over hypotenuse. So sine, and we use our angle. Where did I get the 35 from? It's the angle in question here. So we always need an angle after our sine, cos or tan. So we've sine 35 is equal to opposite, which is x all over 8. Okay, now I want you to think about this in very simple algebra. So if we have 2 is equal to x over 5. Okay, we want the x on its own there, so we're going to multiply both sides by 5. Okay, so you will end up having that multiplying, so you'll end up with 2 by 5 is equal to x, so 10 is equal to x. Now, sine 35 is just a number, okay? So sine 35 is equal to, now, it's not a very nice number, it's 0.57357646, okay? We're not going to write all that down. But if you look here, we want x on its own, okay? To get x on its own, what we're going to do is we are going to multiply by 8 over here, okay? So we end up with 8 sine 35 is equal to x, and we can just pop that into my calculator. So 8 sine 35, and I get out 4.5886, keeps going on a little bit after that. We're looking for one decimal place, so we are going to look at the second number after the decimal place. We'll look at this 8, bigger than 5, so we're going to round up the 5 there to a 6. Okay, so I'm going to show you we'll get the same answer if we do this slightly differently. So if we have sine 35, so we've sine 35 is equal to x over 8. Okay, sine 35 is a number, you can put that into my calculator. So sine 35 is equal to 0.573576. Okay, goes on a little bit after that, but we'll just leave it at that, because at the end of the day, I only want my answer correct to one decimal place. Okay, now, again, we need to get rid of this 8 from the bottom. To get rid of that 8, we'll multiply both sides by 8. So we could have 8 by 0.573576 is equal to x. I'm just going to put that into my calculator. So it'll be 8 by 0.573576, which gives me out 4.5886. To one decimal place, then that's x is equal to 4.6. Okay, we get the same answer as above. The only difference is I put this into my calculator at an earlier stage. Okay, they're the same method, whichever you prefer. This method up here where you don't put it in straight away might give you a slightly more accurate answer, particularly if they wanted it maybe to 3 decimal places, but really they end up being the same thing. Okay, so we're going to do 1 or 2 more examples of that now, maybe using the other versions of cos and tan, just to see how it all works. Okay, so we're given a triangle here. We have an angle, which is 35 degrees. We have a side, which is 10, and we are looking for x. Okay, so I think, okay, I have a right angle triangle. My options when I have a right angle triangle are always Pythagoras or SOHCAHTOA. Pythagoras won't work here because we don't know 2 sides. We only know one side, so Pythagoras isn't going to work, which means I'm going to have to use SOHCAHTOA. First thing I'm going to do, I'm label my sides. So I'll start with my hypotenuse. Okay, HYP. Then I'll have my opposite, which is opposite the angle in question, and then finally adjacent. Okay, so I'm going to write down SOHCAHTOA. Okay, now, here we're actually going to end up using the same formula. I don't know the adjacent. I also don't want to find the adjacent, so any formula with the adjacent is going to go. So we're going to be left with sine. So we have sine A is equal to opposite over hypotenuse. Okay, now my angle in question here is 35, so it'll be sine 35 is equal to opposite, which is 10, all over my hypotenuse, which is x. Now, the algebra here again gets a little bit funny because we're moving things around. I'm going to show you a little trick for that in a second. So sine 35, okay, remember that's just a number. When I put it into my calculator, I'm not going to write this down right now, but it's 0.5735764,364, okay? I'm not going to write that down just yet, okay? We need the x on its own, okay? So we need this, okay? Right now it's at the bottom of the fraction, okay? When we have a simple bit of algebra, so like back here, when we had the 5 on the bottom of the fraction, we essentially brought it over to the other side and it changed to multiply. So we're going to do the same thing here. So we're going to bring the x over here. So that will give us x sine 35 is equal to 10. Now, we're going to do the same thing here, we're just going to bring this underneath. So we're going to divide both sides by sine 35. So we'll be left with x is equal to 10 divided by sine 35. Plug that into your calculator. And we'll get out x is equal to 17.4. Okay, I didn't say here how many decimal places I want. In the question, they will tell you how many decimal places to round to. For this, we'll just go to 1 decimal place. Okay, so up here, we have the x on the bottom. To get rid of a fraction, okay, you multiply both sides by that fraction, by the bottom of the fraction. So I'm going to multiply the other side by x. Okay, now we need to get rid of this. To get rid of that, we'll divide both sides. Now I'm just going to show you the same method, just when we change it to a decimal earlier on, which some people prefer. So I'm going to start from this line again. So sine 35 is equal to 10 over x. I'm going to put sine 35 into my calculator. And I get out 0.573576. Okay, is equal to 10 over x. Now, I need to get rid of this x. To get rid of that x, we're going to multiply both sides by x. So I'm going to end up with 0.573576x is equal to 10. Okay, now again, I'm just going to go up here. We're just going to think about this in very plain algebra. If we had 2x is equal to 10, you divide both sides by 2, you'd be left with x is equal to 10 over 2. This is just not so nice a looking number. So we're going to divide both sides by that. So you'll be left with x is equal to 10 divided by 0.573576. Put that into your calculator. 0.573576. And we get out 17.4 again. Okay, so they're exactly the same method. One, you put the sign into your calculator earlier, one you leave that till later. Okay, whichever you prefer, you get out the same answer. Just for going forward, maybe into leaving cert, if you can follow this is a little bit more accurate when you get to leaving cert, but for junior cert, either method there would be fine. Okay, and I'll do one more down here then. So again, right angle triangle, can't use Pythagoras because we only know one side, so we are going to have to use either sine, cos, or tan. So SOHCAHTOA. Okay, first I'm going to label my side. So my hypotenuse is always opposite the right angle, and then with the opposite to the angle we know, and we have the adjacent to the angle we know. Okay, now in this one, the hypotenuse, okay, I don't know it, also don't want to find it. So any formula with hypotenuse we're not going to think about, so that crosses out those two. So the formula we're going to use, the version we're going to use is going to be tan A, tan of the angle is equal to opposite, which we'll find in a second, over adjacent. So we end up with tan A, so tan 20 is equal to x all over 5. Okay, what we need to do, we need to get rid of this 5, so we have the x on its own, so we're just going to bring it, we're going to multiply both sides by 5. So we'll have 5 tan 20 is equal to x. So 5 tan 20 will give me 1.82 is equal to x. Okay, that's just rounded there to 2 decimal places. Okay, so super important that you can use your calculator for these. Okay, it takes a little bit of practice finding the buttons. You should also note in your calculator that you have a small d written on the top of your calculator. That just means your calculator is in the right setting. Okay, so these 2 examples here, if you can follow both of those, that's really all that comes up in the questions. We're going to see they kind of come into more practical problems. You might be measuring the height of a building or something, but you're still using their basic rules. Okay, so we've done 2 methods there for finding a missing side. We've done Pythagoras, again, doesn't apply in all situations. And then we've used SOHCAHTOA as well. Now, we're going to look at finding a missing angle also with SOHCAHTOA. Okay, so here we have a right angle triangle. We're looking for the angle B. Okay, when you're looking for an angle in a right angle triangle, your only method really is to use SOHCAHTOA. Okay, Pythagoras will not work for this. So first we do exactly the same thing. So we label our sides. So our hypotenuse is also always opposite the right angle. And then we have our opposite to the angle in question, and we have our adjacent. Okay, now label the sides again, and now we need to decide which ratio to use. So I'm just going to do it up here for a second. So SOHCAHTOA. picking out the angle we use here is slightly different, or picking out the trig ratio, so the sine, cos, or tan that we use is slightly different. Okay, so here, we don't know the hypotenuse and we're not going to find it. So that rules out anything with the hypotenuse in it. So we're going to be left with tan, okay? But this time we're not looking for either of them. We know the opposite and the adjacent, but we're looking for the angle, okay? But because we don't know the hypotenuse, we don't care about finding the hypotenuse, we rule out the sine and the cos. Okay, so down here then I've written, so I'll just write out this beside it. So tan is equal to opposite over adjacent. This time the angle we're looking for is called B, doesn't matter what letter it's called. Okay, so tan B is equal to opposite, which is 4 all over 7. Now, anytime you're looking for an angle, okay, so we're looking for this, okay, what you always do is you find the inverse of your fraction, okay? So basically what you do, you swap these two around. So you put the tan, you put the 4 over 7 in the bracket, but you need to press that inverse button on your calculator, okay? So to do that, you press, so to get this button, you press shift and tan. Okay, and then you, in that bracket after, you put the 4 over 7, close the bracket and press the equal to sign, and you get out that B is 29.74 degrees. Okay, this question said to the nearest degree, so you're going to round that up to 30 degrees. Okay, again, that answer looks reasonable. Okay, if you got an answer of 100 degrees, okay, that wouldn't be possible because the angles in a triangle need to add up to 180 and you already have your 90-degree angle. Okay, so make sure your answer is realistic, but remember, anytime you're looking for a missing angle, you need to use the inverse. Okay, so we'll do 1 or 2 examples of that now. Okay, so here I'm given a right angle triangle. My thought process goes to Pythagoras or SOHCAHTOA. I'm not looking for a missing side, I'm looking for a missing angle, so it has to be SOHCAHTOA. Okay, I'm gonna label my sides. So this is my hypotenuse, because it's always opposite my right angle. And then the angle in question here is A, so this is my opposite to that angle. And then this is my adjacent. Okay, now here, don't know the hypotenuse, don't care about finding it. So anyone with a hypotenuse is gone. So we're going to be left with tan. So we have tan A is equal to opposite all over adjacent. So tan A is what we're looking for, is 5 all over 6. Now, we're looking for the angle, so what we do is we swap these two, we put the tan inverse. It's going to be tan minus 1 of 5 over 6 is equal to A. So A is equal to, I'm going to press shift, tan 5 over 6, and I get out 39.8 degrees. Okay, again, a reasonable answer. We use tan again there. Hopefully in the next one now we'll use a different ratio or a different version of sine or cos. So same thing again here. We know two sides. We're looking for an angle. That rules out Pythagoras. So we're going to use SOHCAHTOA. First things first, label your sides. So that's my hypotenuse because it's opposite the right angle. This is my opposite, the angle in question. And then this is my adjacent. Okay, this time the adjacent. I don't know anything about it. I also don't care about it. Okay, I don't want to find it. So anyone with an adjacent is going to be ruled out. So we're going to be using sine. So we know sine is equal to opposite over hypotenuse. So sine y is equal to opposite, which is 7, all over 10. Again, we're looking for the angle, so we're going to get the inverse. So sine minus 1, 7 over 10 is equal to y. So y is equal to, so I'm going to press shift. Sine, you should see that minus 1 popping up in your calculator, 7 over 10, close the bracket and press the equal to sign, and I get 44.4 degrees. I just rounded that to 1 decimal place. It will tell you in the question how many decimal places it wants it to. Okay, so that is the basics of trigonometry. Okay, so when you're studying, you need to learn how to do these bits. Okay, next we're going to move on to practicing some exam questions, okay, or exam style questions. But this is the basics, okay? So this is your kind of, your base level of knowledge you need for trigonometry. So you need to know how to use Pythagoras, how to use the angle formula, so your sine, cos and tan, to find a missing angle and a missing side, okay? So we should be really confident with all this before we move on to looking at more difficult questions and exam style questions. but when we do move on to those now in a second, we're just going to be using all of this knowledge again. So now moving on to some exam questions. Before we do that, we'll just have a few tips. So with the exam questions, so if you see a triangle and it's a right angle triangle, you're going to be using Pythagoras or SOHCAHTOA. Okay, there is another section of the course, geometry, but that will involve triangles that are not right angled. Okay, so the second you see a right angle, your thought process is going Pythagoras and SOHCAHTOA. Okay, and then just my last tip for the practical questions. So if you're finding the height of a building or anything, draw out the triangles. Okay, will draw out separate triangles, just makes their life easier, keep her work nice and organized. Okay, so we're going to start with this question. It's fairly straightforward, just using kind of the key skills that we've learned in the first half of the session. So the diagram on the right shows a right angle triangle. Okay, second I see right angle triangle, I'm thinking Pythagoras or SOHCAHTOA. Use trigonometry to find the length of the side marked X. Give your answer in third form. Okay, third form just means that there'll be a square root somewhere in your answer. Okay, we don't need to worry about that until the very end. So we're looking for the length of the side marked X. Okay, Pythagoras won't work here because we only know one side, we don't know the other side, so we're going to have to use SOHCAHTOA. Okay, so I'm going to write down SOHCAHTOA. And then I'm going to label my sides. So this is going to be opposite, that's going to be our hypotenuse, and then that'll be my adjacent. Now, when I look at that, I think, okay, I don't know the adjacent, don't want to find it, so anyone with adjacent in it is going to go. So I'm going to be left with sine. So we'll have sine is equal to opposite all over hypotenuse. Okay, so we have sine 60 is equal to opposite, which is x, all over the hypotenuse, which is 10. Okay, now if we want to get rid of that 10, we just want the x. We're going to multiply both sides by 10, so it'll be 10 sine 60 is equal to x. So 10 sine 60, put that into my calculator, I'm getting out x is equal to 5 root 3. Okay, that's my answer in third form because it has a square root in it, so I know I'm correct. Okay, third form just means the square root. Okay, then next part. Use the diagram on the right to calculate the value of x. Again, leaving your answer in third form. You know, they don't always say this, it's just a coincidence that two questions in a row. They could either say third form, to the nearest whole number, to one decimal place, etc. Okay, so I look at this, I see I have a right angle, so Pythagoras or SOHCAHTOA. I know two sides, I'm looking for a third side, so that is going to be Pythagoras. So my formula is c squared is equal to a squared plus b squared. Okay, c has to be the side opposite the right angle. After that, it doesn't matter, so I'm just going to call that a and b. Okay, so we're going to say that x squared is equal to a squared, which is 3 squared, plus 3 squared. So x squared is equal to 9 plus 9, which is 18. Now we don't want x squared, we just want x. So x is equal to the square root of 18. Okay, that's my answer in third form. If you put that into your calculator, it will simplify to 3 root 2. Okay, so either of those answers would be accepted because they said in third form, which just means the square root in your answer. Okay, and then the one underneath as well is also Pythagoras. Okay, how do I know that? It's a right angle triangle. We know two sides. We're looking for a third side. I'm going to label my C opposite the right angle, and then A and B don't matter. So I'm going to have 3 squared is equal to 1 squared plus y squared. So 3 squared is 9. 1 squared is just 1 plus y squared. I want to get rid of this 1, so to get rid of that 1, we'll subtract 1 from both sides. They'll cancel each other out, so we'll be left with 9 minus 1, which is 8, is equal to y squared. So y is equal to the square root of 8, or y is equal to 2 root 2. Okay, again, your answer there is in third form. So they're quite basic, they're just directly applying the knowledge, okay? But the part A of a question, of even a difficult trigonometry question, will start off fairly straightforward like that. Okay, now we'll move on to the next one. Okay, so this is more of a real life problem. So the photograph on the right shows a house. Part of the roof of the house is shown in the diagram below. So really now we don't care about the house, we just care about the diagram. AB is perpendicular to DC. Okay, now we haven't seen the symbol yet. Sometimes we used to do our right angles like this. Okay, they can also be done as those little boxes there. So that we have right angles. So AD is 11 0.8 meters. So they already have that marked in down here. They say DB is 2. They also have that marked in. CAD, so to find the angle CAD, you go trace out from C to A to D. So it's that angle in there, which they've marked in as 20. And then the angle DBC, so DBC, this angle here is X. Okay, use trigonometry to work out the value of X. So we're looking for a missing angle. Okay, what I'm going to do, I'm going to draw out that triangle. So I'm looking for my missing angle here. I'm going to draw out that triangle down here. Okay, so I have my right angle here. I have X there, and I know that this is 2 meters. Okay, I'm looking for a missing angle, so I'm going to have to use SOHCAHTOA. I'm going to label my sides. So this here is opposite my right angle, so that's my hypotenuse. This is opposite my angle in question, so this will be opposite, and then this is adjacent. Okay, now I actually can't use any of these yet because I don't have enough information. So I know my adjacent, but to use any of these, I need to know 2 things to find a missing angle. I don't know it. So I'm going to go back up to the question. I'm going to see, okay, there's another triangle there. So we have a big triangle over this side. Okay, so this here is marked as 20. This is 11.8, and this is H. Now, when I look at that triangle again, it's right angled. I'm going to label my sides. So this is my opposite, or sorry, this is my hypotenuse because it's opposite the right angle. This is my opposite, and this is my adjacent. Now, what I could do here, I could find H. Okay, so I could find that opposite side, which is going to link up then over to here. Okay, so we're going to find the opposite. Okay, so I have SOHCAHTOA. Okay, now hypotenuse here, we're not looking for it. We don't care about it. So anyone with a hypotenuse is going to be gone. So we're going to work with tan. So we know that tan is equal to opposite all over adjacent. Okay, so we have tan 20 is equal to opposite, which is H, all over adjacent, which is 11.8. Okay, now I've seen this before. I'm going to bring that over to that side and multiply. So it'll be 11.8 tan 20 is equal to H. So 11.8 tan 20 into my calculator is equal to, H is equal to 4. We'll go to 2 decimal places, 29. Okay, now I'm going to fill that into my diagram up here. So 4.29 is there. And I can also fill that in here, 4.29. Okay, now I have enough information to find my angle X because I know opposite and adjacent. Again here, hypotenuse is irrelevant. So we're going to cross both those out and we're just going to use tan. So we're going to have tan X. So tan X is equal to opposite, which is 4.29, all over adjacent, which is 2. Now, when you're looking for the angle, you need to use the inverse. So we're going to swap the X and the fraction around. So it's going to be tan minus 1 of 4.29 all over 2 is equal to X. Send to my calculator. So tan minus 1 of 4.29 all over 2. So X is equal to 65 degrees. Okay, again, sounds like a reasonable answer. Okay, so quite a bit of work there. We had to find information. We had to find H that wasn't directly our answer. So we defined an answer to find the actual answer we wanted. Okay, but there, drawing out the 2 triangles helps. And remember, even if you don't get to this final answer here, if you worked out H, you'll get some attempt marks. Okay, so we're all the time building up attempt marks, even if you don't get to the correct answer. Okay, suggested time there for that question was 5 minutes. I think it's doable in 5 minutes, but you would want to keep moving. Especially if you kind of don't see the tricks straight away that you need to find H, okay? But it did kind of give you a hint there, it wrote in H, so that might have been a good one to find, okay? So we'll move on to the next one. Okay, now again, here's quite a similar question, two triangles involved in it. So the diagram below shows two right angle triangles, okay? Right angles, we're thinking, okay, Pythagoras or SOHCAHTOA, ABC and ACD. They have right angles at B and D. AB is 10, AC is 12, and AD is equal to DC, which is X as shown, okay? Now, use trigonometry to find the size of the angle Y. Okay, so with this again, I'm going to draw out diagrams. Okay, so diagrams can really help here just to separate the two triangles. So I'm focusing on this bottom triangle here. So this is going to be B, this is going to be C, this will be A, and this is 12. Here's my right angle, and this is what we're looking for, and that's 10 down there. Okay, straight away, label my sides. Okay, so this is opposite my right angle, so that's my hypotenuse. This is opposite the angle I'm dealing with, and this is my adjacent. Okay, looking for an angle, so we're going to have to use SOHCAHTOA. Okay, so we don't know the opposite, we don't know anything about it, and we're not going to find it, so that rules out sine and tan, so we're going to use cos. Okay, so cos is equal to adjacent all over hypotenuse. Okay, so this time we have cos y is equal to adjacent, which is 10, all over the hypotenuse, which is 12. We're looking for the angle, so we know we're going to have to use the cos inverse. So it's going to be cos minus 1 of 10 over 12 is equal to y. So y is equal to, and I want it to one decimal place, so cos minus 1 of 10 over 12. Okay, so remember, press shift and then the cos button to get the inverse. And we're going to get 33.557 degrees. Now, to one decimal place, we look at the number after the, we look at the second number after the decimal point. It's a 5, which means we round up. So that will be 33.6 degrees. Okay, so just be careful with the rounding. It's annoying if you've all the hard work done and then if you're losing marks because you're rounding, kind of a small mistake at the end. Okay, and second part then, find the value of X, giving your answer correct to 2 decimal places. Okay, so my other triangle then is, how do we draw this? So we'll draw it like that. We'll draw it the way it's given to us. This is my right angle here. This is X, and this is 12. Now, when I look at this, again, right angles, we're thinking Pythagoras or SOHCAHTOA. Okay, now we don't have enough information here to use SOHCAHTOA. Okay, so what we're actually going to do, we're going to end up using Pythagoras. Now, I'm kind of contradicting myself a little bit here because I said before that you need to know 2 sides to use Pythagoras. Okay, but this is a bit of an exception because 2 of the sides are the same. Okay, so you'll see what I mean in a minute now. This is going to work out with Pythagoras. If you tried SOHCAHTOA here, you don't have enough information because we don't know any other angle. We don't know what this angle is or this angle is. Okay, now we could potentially find it. Okay, but we are going to go with Pythagoras here just because I think it'll make our lives a little easier. Okay, so the side opposite the right angle needs to be C. And we'll call this A and we'll call this B. Okay, so we'll have 12 squared is equal to x squared plus x squared. So 12 squared in my calculator is 144. So 144 is equal to x squared plus x squared. That's 2x squared. Now, we're going to divide that 144 by 2 to get rid of this 2 in front of the x squared. So 144 divided by 2 is equal to x squared. That gives me 72 is equal to x squared. Now, we don't want x squared, we just want x. So we're going to get x is equal to the square root of 72, which gives me x is equal to 8.4852. We want to correct to 2 decimal places, so we're going to look at the third number after the decimal point. That's a 5, which means we need to round up the second number. So that's going to be x is equal to 8.49. Okay, now there are potentially other ways to do that question. You could spot that it's an isosceles triangle. Okay, but I think they're using Pythagoras as kind of the most straightforward way. Okay, and then you're just into algebra once you have Pythagoras' theorem set up. Okay, and then the final question we're going to do now is which is similar to this, it's going to be the 2022 question. Okay, so this was last year's junior cert question, which gives us a really good idea of what standard would be expected. Okay, so the diagram below shows 2 vertical buildings A and B. Diagram's not to scale. Okay, so you can't measure them or anything like that. Mary stands at the top building of A. She is 220 meters above the ground. So this height here is 220 meters. She wants to work out the distance marked Y and Z in the diagram. Okay, so you can see Y is kind of the slanty one going down this way, and Z is the height of building B. That is the distance from the top building A to the bottom building B and the height of building B. Mary measures two angles that are marked 35 and 20 in the diagram. Broken line is horizontal. Okay, so we have a right angle here and we have a right angle here. First thing we need to do, we need to work out the size of the angle C. Okay, so angle C is in this triangle here, so we're going to draw out that triangle. This is C, this is 220, this is 35. Okay, and then this is 154. Now, there are a few ways to do this, okay, but we're going to take a little bit of a shortcut, okay? For this, now this isn't necessarily trigonometry, it kind of comes more into geometry, but we should know that three angles in a triangle must add to 180 degrees, okay? So this is 90 degrees down here because it's a right angle. So we have 180 minus 35 minus 90 will give us our answer. 180 minus 90 minus 35, which will be 55. Okay, so C is equal to 55 degrees. Now, of course, you could have gone, we had enough information there to do SOHCAHTOA, so this would have been my opposite, this would have been my adjacent. Okay, but there was no need to do it there. When you know the fact that three angles in a triangle must add up to 180 degrees, we're just able to subtract the other two. Okay, good practice there to see if you get out the same answer using the alternative method, which you should. Okay, then Mary works out the horizontal distance between the two buildings is 154 meters. Use Pythagoras Theorem to work out the distance marked Y in the diagram. Give your answer correct to the nearest meter. Okay, really nice here that they told us to use Pythagoras Theorem. Okay, so we're going to draw out, this is the side we're looking for, so we're going to draw out this triangle again. Okay, so we have one side here, which is 220 meters. We have the bottom, which is 154 meters. And we have our Y here. And this is my right angle. They told us to use Pythagoras. We should be able to figure that out anyway, just in case they didn't in a question. Pythagoras' theorem, C squared is equal to A squared plus B squared. The only important thing is which one I label as C, which has to be opposite the right angle. So that's going to be my C, and I'll call that my A and B. Which ones you call A and B, again, doesn't matter. So now we have Y squared is equal to 154 to be squared plus 220 to be squared. So Y squared is equal to, I'm going to put those into my calculator, so 154 squared, okay, is 23716, plus 220 squared is 48,400. I'm going to add those together. So I get out 72,116. Now, I have Y squared, I don't want Y squared, I just want Y, so Y is equal to the square root of 72116. So we want it to the nearest meter, so I'm getting out 268.5 meters. Okay, to the nearest meter, this is a 5, so we're going to round up, so Y is equal to 269 meters. Okay, so a really nice question there, they even told us what to use. Okay, and then part C, use trigonometry to work out the value of Z. Okay, so Z is the total height from the bottom of the building to the top of the building. Now, I know some of this already. So I know up as far as here is 220 meters. So I just need to find this bit here. I'm going to call it X. Now, I'm going to use that top triangle. So I'm going to take out this triangle here. So I'm going to draw that in. So it's at the bottom, we're 20 degrees and we're right angle there. So that's going to be 20. Now, we know the length of the bottom. So here is the same as there. So here's going to be 154. And I'm going to call that X. Okay, we're looking for X. It's a right angle triangle. Don't have enough information to use Pythagoras, so we're going to go with SOHCAHTOA. Okay, so this is my opposite. So hypotenuse first, then my opposite, and my adjacent. Now, don't know the hypotenuse, don't want to find it, so that's going to rule out these two. So we're going to be left with tan. So we're going to have tan is equal to opposite over adjacent. So tan 20 is equal to x over 154. We've seen this a couple of times now. To get rid of the fraction, we bring that over to the other side and multiply. So it's going to be 154 tan 20 is equal to x. Onto my calculator. So 154 tan 20. So x is equal to 56 meters. Okay. So I can fill that back up in my diagram here. Be careful now, you go back and read your question. That isn't our final answer. So that's 56 meters. So the total height of building that B then is going to be 220 plus 56. So height of B is equal to 220 plus 56. So 220 plus 56 will give me 276 meters. Okay, really important there to read your question carefully. Okay, a lot of people would have found x there, but they wouldn't have continued on to find the actual height of the building. Again, think about it like that's a part C of a question, so that further down the question you get, the more challenging they tend to be, so you're kind of expecting a bit of a trick there. Okay, that was the 2022 question. I think it was very manageable, especially when they told us to use Pythagoras Theorem in part B. And you had a few options then for part A on how to do it, but I think when you know that fact that three angles add up to 180, you'll be covering that a lot in geometry, so there's a bit of an overlap there. Okay, but overall I think a very manageable trigonometry question for 2022 Junior Cert. We're just going to look at two questions that I think might be a little bit more challenging. Okay, so they are still applying the basics of Pythagoras and SOHCAHTOA, just maybe not in as obvious a way. So we'll look at this one first. So in the diagram shown, the length of a side of the square is x centimeters. Okay, now before I go any further, okay, key word in that sentence is square. Okay, so we should know a square, all the sides are the same. So if this side is x, that side is also x, that side is also x, and that side is also x. Okay, thinking what else do I know about a square? Okay, squares, right angles at every corner. Okay, just some information that kind of came to my head when I saw the word square. Haven't really gone any further with the question yet. Find the length of the diagonal of the square in terms of x. So the diagonal of the square goes like that. Okay, so we're looking for that. We're going to call that, call it y. Okay, giving your answer in third form. Now, by drawing in that diagonal, I've essentially made two triangles. Okay, so we're going to draw out the left-hand side triangle there. Okay, this bottom side here is x, this side here is x, and this side is y. Okay, my right angle here. Now, in terms of x, right, what does that mean? We see this bit in algebra. We want x in our answer. Okay, now when I look at this, I have a right angle triangle. I don't know anything about an angle. So when I have a right angle triangle, I don't know anything about the angle. My only other option then is Pythagoras. So we'll label our sides. This is opposite the right angle, so that must be my C, that must be my A, and that must be my B. I'm just going to fill in my formula. So we have C squared is equal to A squared plus B squared. So we have Y squared is equal to X squared plus X squared. Okay, we'll keep going with my algebra, see where that'll bring me. Y squared is equal to 2x squared. I don't know what happened there. Y squared is equal to 2x squared. Get rid of the squared by squaring both sides. So y is equal to square root of 2x squared. Okay, and then suddenly y is my diagonal. So the diagonal is equal to the square root of 2x squared. Okay, that is my answer in terms of x, because we have an x in the answer. So yeah, that's that question. I think a little bit more challenging just to kind of spot, okay, this is a trigonometry question because it started about a square. Okay, so you might be kind of jumping there in volume. You can use your trigonometry there to apply to that. Okay, so the next one then, okay, so carpenters and builders regularly use triangles with sides in the ratio 3, 4, 5 to make sure they're constructing a precise right angle. Okay, so basically that's a subtle way of telling us that this is a right angled triangle. Okay, part A then says indicate the right angle in the diagram below, ensure that it is clearly labeled. Okay, now all along when we've been measuring or when we've been marking the right angle, okay, the hypotenuse is always the right opposite the right angle, right? What hypotenuse means is the longest side. Okay, so the right angle and the hypotenuse are always opposite each other. So here the longest side is 5. So this must be my hypotenuse. So the right angle must be opposite that. Okay, so that's me after marking in my right angle there. Okay, hypotenuse is the longest side and the right angle is always opposite the hypotenuse. Okay, so that might be kind of new information, a bit of kind of a jump up, but I think should still be okay. So hypotenuse is the longest side and the right angle is always opposite the hypotenuse. Okay, next part. Use a theorem from your course. Okay, so there's a few theorems linked to geometry. You may not have done geometry yet, but from trigonometry, I'm immediately thinking of one theorem. Okay, Pythagoras Theorem. We're going to read the question first. So use a theorem from your course to prove that triangles with sides 3, 4, and 5 have a right angle. Okay, triangle, theorem, right angle, all of those point to Pythagoras. So Pythagoras's theorem. Okay, so I'm going to draw out a triangle with sides 3, 4, and 5, like above. I'm going to draw it out the way we're used to. So, it could be 5, 3, and 4. So just kind of flip that on its side there. Okay, now we'll label our side. So Pythagoras' theorem says that c squared is equal to a squared plus b squared. So this is c, this is a, and this is b. Okay, now that will leave us with 5 squared is equal to 3 squared plus 4 squared when I fill in my formula. Okay, I'm going to work this out and see what I end up with. So 25 is equal to 9 plus 16. 25 is equal to 25. Okay, now obviously 25 is equal to 25. Okay, so that worked out. Okay, so Pythagoras' theorem worked. Okay, so when we use the numbers 3, 4, and 5, it worked. Therefore, triangle is right angled. Okay, if they give you different numbers and you didn't get the same number both sides of the equal to sign, then you could say that the triangle is not right angled. Okay, so if Pythagoras' theorem works, the triangle is right angled. Okay, so it's kind of useful. It's kind of using the theorem in the opposite way. So we usually use it to find a missing side, but it can also be used there, kind of a bit of a step up, but it can be used to see if a triangle is right angled or not. Now moving on to part C, it says use trigonometry. Love that word because the second I see that word, I'm like, it's either Pythagoras or SOHCAHTOA, to work out the size of the smallest angle in the diagram above. Okay, now the diagram that they drew is the same as this diagram here essentially. Okay, so I'm going to work with the one that I drew just because it's the kind of usual way we're used to seeing a triangle. So I have my side, I have 5, 3, and 4. Okay, so we're looking for the smallest angle. Okay, now we set up here earlier that the hypotenuse is the longest side and it's always opposite the right angle. Okay, so basically the biggest side is opposite the biggest angle and the smallest side is opposite the smallest angle. Okay, so my smallest side is 3. So the side we're going to be looking for, or sorry, the angle we're going to be looking for is this one here. We're going to call it x. Okay, so the smallest side is always opposite the smallest angle. Okay, we're looking for an angle, so I'm going to have to use SOHCAHTOA. So we're going to label the hypotenuse first, which is always opposite the angle or the right angle. Then we have our opposite, which is opposite the angle in question. And we have our adjacent then. Okay, I'm going to write down my formulas. So SOHCAHTOA. Okay, now usually there's only one we can pick, but here we can see we're looking for a missing angle. We know all the sides, so we can actually use whichever one is your favorite. Okay, I'm going to use sine is equal to opposite over hypotenuse. It doesn't matter. Okay, you can pick whichever one you want to get the same answer with them all. So you're going to say sine x is equal to opposite, which is 3, over hypotenuse, which is 5. Now we're back to normal trigonometry. So we're looking for a missing angle, so we need to use the inverse. So it'll be sine minus 1, 3 over 5 is equal to x. Pop down to my calculator. I get out shift sine minus 1 of 3 over 5 is equal to 36.8 degrees, okay? Go on to the nearest degree, so that's 37 degrees, okay? Now, I'm just going to mark in my angles just to kind of double check here. So this is 90. This is 37. Now, we're going to find this one up here. So 180 minus 90 minus 37. So that angle up there is 53. Okay, so my smallest angle is definitely 37. Okay, if you were unsure about, if you didn't know the thing that the smallest angle is opposite the smallest side, you could have just found the two angles and then picked the smaller version. Okay, so I would say that question there is just a little bit trickier. It's still applying your basic rules, so there's no more to trigonometry at junior cycle than Pythagoras and SOHCAHTOA. It's just kind of maybe not as obvious there that you need to use them. Okay, so it's the end of this session. It's going to leave you with some tips. So learn the formulas. By that I mean your SOHCAHTOA. Okay, learn how to remember those, whether you have a different rhyme. Doesn't matter, just figure out a way that you'll be able to remember them and know when to apply each. Okay, so I think that crossing out method when one side is irrelevant to the question works quite well. Draw out your triangles, especially for the practical problems. When you're studying this, okay, now you may not have them done yet. It depends how many chapters you've done. When you're studying them, I'd make kind of a link to geometry and constructions, okay, because they're similar content and the questions often overlap. Okay, so maybe that's a point for later on in the year when you have the whole course covered and you're revising, but there's quite a strong link between these chapters. Okay, and then finally, practice, 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 the same as all chapters in maths, but especially with this, you need to kind of be working it out, practice drawing out your triangles, etc. Okay, so best of luck. I hope you found this video helpful, and yeah, best of luck with practicing your trigonometry.